Good morning or good afternoon, ladies and gentlemen. Today is Tuesday, March 23rd, 2021. Please go ahead and turn your water filtration lab into Canvas via Cami if you are a digital student, and turn it directly into the basket if you are a face-to-face student. So over the weekend, I had you tally how much water you or your family used in a single day. So we're actually going to take a look at this now. So go ahead and open up to that information. You will want to open a new tab in Canvas and then go to the Water Walk Reflection Assignment. So just tracking your water usage instead of just using it. Did anything surprise you? Did it segue into any sort of conversations at home with your parents, guardians, siblings, or grandparents? How many gallons do you think you used? We're actually going to find out now. So, every time you flush the toilet, you used about 3.5 gallons of water. So go ahead and tally how many times you flush the toilet and then multiply that by 3.5. And it will tell you how many gallons you used just flushing the toilet over this weekend. 1 minute in the shower is approximately equal to 4 gallons. So multiply how many minutes you and or your family that participated used the shower. How many minutes was that? Multiply that by 4, and that gives you how many gallons you used showering. 1 minute of hygiene. So this is things like washing your face, washing your hands, brushing your teeth. It's a smaller sink than obviously having a shower open. So that's going to work out to about 1.5 gallons per minute. So figure out how many minutes you had of hygiene and then multiply that number by 1.5. That gives you how many gallons of water you used on hygiene alone. Finally, 1 cycle of dishes is 6 gallons. So how many loads of dishes did you do in the dishwasher? Multiply that by 6, that gives you that. If you did any dishes by hand or if you pre-rinsed them, you should have how many minutes that was. You are going to multiply that by 2.5 gallons per minute. So if, for example, you had 5 minutes of hand washing dishes in the kitchen sink, the rate of that kitchen sink is 2.5 gallons per minute. And then finally, 1 load of laundry is 40 gallons. This is what kills Mrs. Gerhardt, having 6 people in the house. So 1 load of laundry is approximately equal to 40 gallons of water. So multiply the data that you collected by this information and then total it. And that will give you how many gallons of water you used or however many people in your family participated this weekend used. Okay? So the global water crisis is a big problem, but it is solvable. And the solutions depend on the type of scarcity that exists. So remember, economic scarcity versus physical scarcity. So what are some ways to conserve water in water abundant areas? What are some things that we could do living here in Central Florida to conserve water? And then think about what are some ways to address the water crisis in areas with physical scarcity or economic scarcity. For physical scarcity, think about Las Vegas. For economically scarce regions, think about Bangladesh. If you need more time, please pause me. Welcome back. This is a video from National Geographic about the water crisis.
Our lifestyles are very thirsty, and it's not just the water that comes out of the tap at home. If we think about our daily lifestyle, everything we use and wear and buy and eat takes water to make, and sometimes really a surprising amount. It can be 30 gallons of water just to make a glass of wine. Energy is another really water-intensive thing. It takes about 13 gallons of water to make 1 gallon of fuel. To the extent we can walk, carpool, bike, those are saving energy, but also saving water. Do we have to have brand new clothes? Can we share? Can we recycle? Every time we get something from a thrift store, we've got something new, but it's not taking additional water to make it new. So there's a lot of opportunity to actually be part of the solution. Most of our water use and water management has been around controlling water with dams and diversions to supply water when and where we need it. And that's allowed places like the Western United States to really grow and flourish and expand and become major food producing areas for the whole nation and parts of the world. What we haven't done is really bring nature to the table. We haven't really decided that ecosystems themselves deliver a lot of benefits to us, which they do in the form of purifying water, fish and biodiversity, habitats, clean drinking water. And so I think governments and industries that are figuring out how water is allocated and used can begin to bring that important piece of nature into the picture. And policies can help do that. Markets can help do that. In some ways, I think the new frontier of water management is going to be bringing together efficiency technologies like drip irrigation, which is used in agriculture, with information technologies that allows us to know how much water is really in the soil right now. How much water do those crops really need, so that we can target delivering just the right amount of water when crops need it to make sure that they get what they need, but not necessarily more than they need. Right now, agriculture consumes about 80% of all the water that's used in the West. And so if we can get more efficient and more targeted about delivering that water, we can free up water for the natural environment.
All right, so next we're going to look at 6 water purifying devices that would create clean, drinkable water in the developing world. So the first is the Life Straw. You may actually be familiar with this one. So it is small, it's a cigar shape, it's kind of a tube, and it has some incredible innovation. So the Life Straw actually purifies water from potential pathogens before they ever reach your lips. It's very inexpensive. I believe that you can buy them off Amazon for $12 to $15 a piece. And it is actually considered an icon of humanitarian product design, simply because it is small and portable, it's easily used, it can be mass produced, and it can be mass delivered. So those would all be some pros. Small size, that it's inexpensive, that as long as there is a water source, it filters and clarifies and cleans the water so that it is drinkable. Can you think of some cons? I can. Look what the woman in this picture needs. She has to have a source of water. So this would be good for an economically scarce area, but would it be able to serve those in a physically scarce area? How long does it last? Do I know when it's no longer purifying my water at its fullest potential? Is there something to show me and tell me that? And if so, how do I get a new one? So replacement is also a problem on the Life Straw. Ceramic water filters have become really popular in Cambodia. They saw a 50% drop in diarrheal illnesses since they were first started to be used back in 2002. That's really significant. So the filters are made from fired clay, and what happens is that the tiny pores of the ceramic are small enough to virtually remove all bacteria and protozoa. And then it just uses gravity to help facilitate the filtration process, which can result in a flow rate of 1 to 3 liters per hour. So, what are some pros? It has dropped diarrheal illnesses. They're very successful. They're not expensive to make. What are some cons? You have to have a way to fire the clay. And what if you are trying to serve a larger community or a larger family? 1 to 3 liters per hour may not be sufficient. So this is a water purifying bicycle out of Japan, where bicycles are very, very common. They call this the CycloClean. And basically, it was initially designed for use in very rural areas and disaster zones. So it harnesses kinetic energy from the pedaling to purify water. So basically, what can happen is you can ride a bike to any nearby body of water, and you suddenly have an immediate access to drinking water. So I want you to pause and I want you to think about, what are the pros here? What are the cons? Please come up with at least 2 pros and at least 2 cons for the water purifying bicycle. Four is the life sack, and I love this picture. I love that look on that little guy's face. So this is really cool because it is multi-purpose. The life sack will actually double as a container for shipping grains and other foods. And then once you receive your package of food, you can then use it as a water purification kit powered by the sun. So basically, you take the UVA radiation from the sun into the bag's thermally treated siding, and then it basically changes the radiation into heat so that it can kill the deadly microorganisms and bacteria. The other really cool thing about this is that it can be worn on your back as a backpack. So this is truly a genius in design, and it's so multifaceted, and it can be used for so many different things. So please pause here. I would love for you to come up with 3 pros and maybe 2 cons for this one. Five, these are water bottles with UV filters. And so they can actually filter water very, very quickly in as little as 2 minutes. And basically what they do is they have very, very tiny water filters in them and then a wind-up ultraviolet system. You can see that wind-up system at the top. And between the UV treatment and the wind-up removal system, it can remove 99.9% of impurities from any water source. And then the inventor of this had actually done some extensive traveling in Africa, and he was really frustrated with the fact that the water still tasted bad. So it was his goal that not only would the water be clean and safe for drinking, but that it would also taste good. So you may definitely want to put that one down as your pro. Please see if you can come up with 3 pros and 2 cons for this. 6, the solar ball. I think that this one is so cool. And basically, it's harnessing the power of the sun to purify the water. So what you do is you put your dirty water in the bottom, and then the solar ball heats up because of the sun, and your clean water is going to evaporate into the top part, and then your sediment and your particulate matter will stay in the bottom. So the condensation alone can yield 3 quarts of water per day. It's an inexpensive solution and it's fairly small, which makes it easy to transport. So I think that you could probably put those things down as a pro right away. But I want you to think what 3 liters actually looks like. And is that enough? How many of these solar balls would you use? Remember that a soda container is 2 liters. Would 3 liters get you by for everything you need to drink and use for bathing, showering, cooking, hygiene in a single day? Just food for thought. Try to come up with 2 cons for the super cool solar ball. So if you have not yet finished your science news, new ways to clean up polluted sources of drinking water, I would like for you to work on that now. It is due at the beginning of next class period. For periods 4 and 6, that means it is due at the start of class on Wednesday. For Digital Campus, periods 1, 3, 5, and 7, that means that it is due at the start of class on Thursday. Please use this time advantageously.